Hello there. I got a package. This is a package I've been waiting a long time for. Fairly excited about it. Where's the see one here? I'll just go for it here. Oh, that's a real. Oh, I hate that stuff. Wow, this is a, I didn't think he was going to send me one of these. This is an actual CD32 original power supply there. Actually very well. I was worried about packages. Old stuff that takes a long time to get. So this, of course, is two broken CD32 motherboards. Yeah, all I'm concerned about is this, that they are complete. Let's do a flyover. I expressed to my friend a desire to purchase a couple of motherboards and was just kind of in stasis for a little while, and I found out that from another person who I had contact with that I could get a refurbed CD32, and so I went ahead and I figured that I should have an actual working one to work off of, and so I got that first, and I think I did it on an unboxing video. Yeah, I did, and I put a Terrible Fire 330 in it, and so I have a working one, and then I have these two supposedly broken ones, and what we're going to do is we're going to attempt to fix at least one of these. If I'm really lucky, I can fix both of them, but I wanted two because chances are I can make at least one working board out of these two. Cross my fingers. The only other thing worth mentioning is in the midst of fixing a CD32 for my friend, extra parts were acquired, and I wound up with a shell and a drive of a CD32. I actually have two optical drives. One of them is definitely broken. It's got a busted gear, and the logic, the DSP board that's on the drive is also bad. That was a situation where I had two drives and I put the parts together and made one working one to give to my friend. But I ordered another CD-ROM drive, and I have that, and an empty CD32 shell, and the only thing I needed was, I believe, a power supply, which I have now, and a motherboard to go in it. So hopefully we can make at least one of these work, so we can come up with another CD32, another functional CD32. So let's cross our fingers. Let's use our brains. Let's put our thinking caps on, turn our thought valves on, and we will do our best to try to fix these. The included power supply is a little bit swollen. I don't know if you could see that. And also there's something loose inside, so I'm going to need to pull this apart. Looks like the bottom comes off somehow. Anyway, I'll set that aside for now. But for now, we're going to use it to prop up our monitor. Okay, so we need to come up with a name for these boards so we don't get them confused with each other. And let's see, how about Biden and Trump? That's guaranteed to make 100% of the viewers mad. Okay, never mind. So what are we going to name these guys? Tweedledee and Tweedledum, how about that? Okay. So on Tweedledum, we're just going to check our power rails, you know, the main input. By the way, if you hear some voices in the background, that's just my girlfriend teaching from home. She's literally talking to her students right now. So there are 6 wires or posts coming out of the switch, and only 4 of them are going to be used because in the off position you don't want anything connected. So it's in the off position right now. And I'm just going to, the top ones I know are dead, so that means that the ones underneath, so the 2 top ones, let me get something to point with here. The 2 top ones here, this one and this one, you could cut them and it wouldn't make a difference, but you leave them there. I mean, it makes the switch more stable. So the ones underneath, right here in the middle, there's some right next to the board. Right next to the board there. Then you've got the one in the middle, and then you've got these ones on the top. So when the switch is in the on position, it connects. The one here is connected to this. So this goes to the power supply. No, wait. No, I think the middle one goes to the power supply. Well, let's just test that out. This is Amiga PCB Explorer. So if you Google Amiga PCB Explorer, you'll come to this site, and they've got several different models of Amiga in there. And what's nice is that, I've shown this in my other videos, that you can click signals and traces on your board, and it will show you the path. And if you just hover, it'll show you the path. If you click it, it'll bring it up here. And let's say you can't really, well, let's see this blue one right here. This blue one right here, I clicked it, so it came up here, and it shows me all of the points on the board. So these 2 top ones are the power rails. You can tell that actually easily by the fact that I think one of these comes over here and goes to the bus connector. But basically what I did was I said, well, I think these 2 middle ones are coming from the power supply. So what's nice about PCB Explorer is you can hover over items and they will give you they'll highlight the board and tell you what the actual pin is that you're hovering over. And we can see that one's VCC, so that's the 5 volts. And if we hover over this one, we see that's our 12 volts. So that means that these 2 are coming from the power supply. I should get partial continuity because there's resistors and capacitors and other passive and active components bridging somewhat of a continuity between the rail and the ground. It's going to be something of high resistance, otherwise, you know, the thing would short. And that's what we're doing right now. We're checking to make sure that we don't have a low resistance between. There's a nice convenient ground pad right here, and I'm just going to test. Turn the switch on. I can't really get to the ones on the bottom real easy, but if I turn the switch on, this is going to be our 12 volts, and this is going to be our +5. So we'll do that now. Alright, so we're on the ground pad here, and we're going to turn the switch on and go here to the +5. That's fine, there's a high resistance there. And an even higher resistance there. Okay. Let's check this one. Turn the switch on. Whoa. That switch is a little... How you doing? Okay. We're getting the same measurement, by the way. My multimeter set to diode test is giving me 200 ohms. A little more on this one, actually. Okay, well, there we go. See if I can hold my probes here. I wonder if there's something wrong with that switch. Yes, there is something wrong with the switch. Okay, so the switch may just need to have some contact cleaner on it, but I don't see any dead shorts as far as the power is concerned on these, so I can't really wait longer. I want to see what's going on with these. Tweedledee. Nothing. Composite. Man, that switch. Yeah, there's nothing going on in that one. Nothing at all. Second board. Nothing. That's not good. Tweedledum is showing a little more life than Tweedledee because it's cycling. It was cycling its boot up. It was doing that, and then it was doing that again and again. See if we can get it to... Probably can't tell any of that because on the CRT it's flickering on the camera. Okay, well the next thing I'm going to do is I'm going to start on Tweedledum because I think that there might be more activity going on here. I'm just going to test my voltages and grounds. So I'm going to use that schematic from Amiga PCB Explorer and just check my rails first. Okay, I've been fiddling around with this a little bit and I have a slight update. So Tweedledee has what I believe is a bad power switch. You turn it on and you have to wiggle it, but that doesn't fix the problem. Now what I've done is I wanted to see what was going on. The LED can sometimes be an indicator on the Amiga CD32. So I plugged Tweedledee into this and it goes dim and then bright and then just stays bright. Tweedledum has a different symptom. Tweedledum is dim and then bright, and then it begins to flicker. I can actually show you here. So we're dim, bright, and then we've got blinking. I shouldn't say flicker, blinking. Yeah. And every time it cycles through and does it again, we get kind of like a reset on the screen. You can't even see, but yeah, there it goes. Okay. Actually, we got a white screen just then. So I believe this motherboard is a little closer to being alive. If anything, the other one has something perhaps wrong with one of the power rails or something. I mean, it just doesn't even get this far. This one's definitely getting farther, so we're making progress, slow but sure. So I guess the next thing I want to do is probably find out if it's chip mem or something. You know, DiagROM should be helpful to me. Now, what I've done is, because I have two of these to fix now, and for future reference, I took this old keyboard extension cable and put jumper pins on the end of it, or, you know, I forget what you call these, but yeah, just put some of these on it so that I could easily plug into them and just test them. And I wrote down what colors they are. I don't use this cable on anything because I wrote down the colors that I have here and how they orient to the plug, and also on the back side I wrote if I was looking at the socket to see, because a lot of times when you're looking at a schematic of a device, it's only just giving you the pinout from the perspective of the socket. So if I'm looking at that, I can go here and look at the colors there. And I also have this that I've managed to come up with. Now, I believe the schematic, I think I've already said something about the schematic for the keyboard port being wrong in this Amiga CD32 schematic, that it's got the send and receive reversed, but I believe the whole jack is reversed, because I don't believe that they should put the pin out from the cable end in the schematic. They should have the socket of this actual pinout looking from a perspective at this. But I'm fairly certain at this point that VCC and ground are swapped, if you were to believe that. So in the R3 CD32 release 3 schematic, it says that VCC is over on this side, and it isn't. It's ground over there. So I mean, you're obviously looking at it from the back side or something. I don't know why that would be. I just think that it's backwards and the schematic is wrong yet again. But anyway, so we're going to proceed with DiagROM on this and see if we can get any farther. Okay, we have the DiagROM in there now. Let's see if it does anything different here. Okay, this is actually good, I think. Yeah, actually, we've got DiagROM's actually working. Yeah. All right. Well, this is really good news. Look at that TV. I mean, I'm looking at a screen that is just static, you know, like a dark screen. And, you know, it's ridiculous. Anyway, I just fixed this Manhattan mouse, and it works great. So hopefully be able to use that. And see this right here? There's some flashing that's actually happening. It's flashing in sync with the light, and that's actually testing the memory. It's not in color, so that's really hurting me because it would tell me. I was hoping to be able to use this monitor, but I don't think it's helping me. Trying to think if I have a composite to VGA, that would be ideal. Let's try some of the other. Complete memory detection. Total amount of memory detected, 0. See, I don't think that this should even be able to run if we don't have any functioning chip RAM, but maybe some of it's working, but I can't, pretty sure it says it on the top of the screen, but I can't see it. So I'm gonna have to set myself up here a little bit differently. I've tried graphics tests. You know, there obviously is something still wrong with this because this is not, you know, if I tried it, well, the memory test part is this test detected chip mem. It has never worked right for me. When I've tried it with OCS Amigas, it comes up with a bunch of errors. When I try it with this one, with the CD32, it just like freezes and doesn't do anything. I guess I could let it run a really long time and see if it eventually does do something, but yeah, whatever. What I do here is it says complete memory detection, and it's very quick, and it says that there's no memory detected, and I don't even know if that's accurate. So I think what I'm going to need to do is bust out my working CD32 and actually compare results. But this is, at least it's looking promising for this CD32 motherboard. There's probably just one component failure on it, or perhaps it was the ROM chip, you know? I don't remember if the behavior of DiagROM on one of these is correct. Anyway, so I'm going to get my other CD32 out here and compare the results, and then I'll also take the other broken one, Tweedledee, and try it here too. I've put some contact cleaner and moved the power switch back and forth a bunch of times, but it still kind of doesn't feel right, you know? It's supposed to be nice, and I might actually have a power switch to replace that, but I don't know if I'll bother. You know, if for some reason this isn't worth saving or has something really bad wrong with it, you know, I'll just use this for parts, you know. Anyway, so let me get started. So here we have a good working motherboard, and I'm going to put the DiagROM in it and probably take pictures of various screens I go to, maybe make some notes or whatever, and determine what I should be seeing. I'm going to get started on that, and I'll come back with some results. Okay, so yeah, I knew this at one time, like a year ago, last time I used DiagROM on a serious basis, but basically the first option, the chip mem test, is just not very good. It won't work in a lot of Amigas. I've tried it. There's something about old Amigas, like maybe because they don't have the AGA chipset, they don't have 2 megs of chip RAM or something, but it doesn't work very well. Looks like the test is almost done here. I think it is. I think that's 2 megs. Anyway, so this is the extended chip mem test. Sorry for the screen. There's no way I'm going to be able to get that to look good because I've switched to just the regular composite out. Seeing as I've pulled a TV out here anyway, the only way I can get color. And it's important because these green zeros will change color when there's an error. I think they might show a 1 also, but it just makes it a little easier to read. So a good test is the extended chip mem test, and you'd think that, okay, extended chip mem, you mean like chip mem greater than 512 or a regular Agnes, fat Agnes? No, it's actually kind of misleading. The test is an extended test. It doesn't it should say extended. It should say chip mem extended test or something like that. It's vague the other way around. It says extended chip mem test. It's like the extended chip mem. No, the test is the extended part. Also, in the main part of the screen, where is it? Go back. Go back. System info. System info is actually a pretty good test. It tests the ROM, which, I mean, we have DiagROM, but it's actually testing, I believe what we're doing here is we're testing the ROM registers and the ROM's interaction basically with the rest of the board. I'm thinking the ROM checksum test. I don't know. I mean, this ROM test could be useless for the fact that we're actually booting from DiagROM, and DiagROM's always going to think it passes, or it always will pass if it's working. But it does have the custom chipset hardware registers reporting up here. Now, doesn't occur to me that that's actually a test. It's more of just a display of information, but you know, that might be useful if you're going into some really fine-tuned diagnosis, of which is actually beyond me because I am not familiar with the low-level programming part of an Amiga, you know, the assembly language part of it, and that's where hardware registers would come into play. You know, you're not going to use hardware registers as information normally when you're just using an oscilloscope, you know, to diagnose a hardware issue. So anyway, right, so yeah, IRQ and CIA is probably not going to pass because there's no CIAs on a CD32. The graphics test, one of these froze here. This one froze. This one actually froze on the, let me write this down. The 200 pixel test froze on bad motherboard. Drew a color bar on good motherboard. So there's a marked difference between the two. Yeah, test picture, that worked in the other one. But the test screen, this one's using the graphics processing ability to draw those, you know, that's a guess because it's drawing it slowly relatively, you know, it's not instantly displaying it. So it's not just taking an image out of the ROM's memory and displaying it, it's actually generating something. Test scroll. Oh, that's interesting. Test scroll does what it says. I'll just say works on good. And test raster, that's a good one. So anyway, alright, so those all work on this computer. Let's just say that, yeah, they all work. And so is it possible that Tweedledum is basically just You have to remember that when a CD32 turns on, it has to check for its CD-ROM, device or whatever to see if there's something in there, and it also will just, when it doesn't find anything, it'll display that animation that comes out of the ROM. I believe it's the only place to store it, but it's not doing that, and so. The only thing that might be wrong with this Tweedledum, the one that almost works, the one that's closer to working, the one we've been dealing with, is that it might just have a graphics problem, which could be the chip mem, but we're going to do the chip mem, extended chip mem test right now. By the way, I took the ROM out of the working motherboard and put it into Tweedledum, and it's doing exactly the same thing. So we can almost assume, almost believe, a pretty good chance that there's nothing wrong with the ROM in there. But we're not going to approach that right now. We're going to simply plug DiagROM back into our bad motherboard and run those tests. So I'm going to do that right now. I'm going to take the ROM out of the bad one and just verify. Yeah, okay. I just wanted to verify the correct operation when I don't have any peripherals, well, mainly the CD-ROM connected. What does it do? So it does that, and the ROM from the broken motherboard is definitely good. Well, definitely most likely good. Actually, I'm just going to leave that in there for now. And place this safely somewhere else out of the way. Very encouraged about the results of this motherboard. It's not completely dead, although sometimes that completely dead motherboard is easier to fix because, well, you just have something wrong with the power rail, you just have to find one of the voltage converters or something on the board. I've heard that those go bad on some people's boards, and so that's what I'm going to look into on the other board. But this one's definitely, I would have to say we're definitely dealing with a custom chip or some sort of video path error. But we're going to see. We're going to see here. All right. So, yeah, this is actually normal. Everything here is normal. Haven't needed to use my serial thing. Okay, so system info, right? All right, it does do a ROM checksum, but again, we expect that to work because I think that's just checking DiagROM, And DiagROM we know works. We're not trying to fix DiagROM. There's not really anything there useful. So let's try these memory tests, and this one especially, the extended test. We're now going to determine, hopefully, if the chip mem on this board is working. So we can rule that out, and that would be nice. Now there still could be a problem with a Kiko. At this point I would be looking at something with a Kiko or video output. I have to sort of figure out how the boot up sequence interacts with video output, and I think it has to do with the displaying of that CD32 startup animation. I think it's not able to display that. Yeah. And so going into the video test, the graphics test, is going to determine, to verify if we have bad, some video circuitry issue. And then we'll just maybe look on the schematic and check our caps, our capacitors in the video output, you know, wherever they are. Check them out. I certainly didn't see any problems with the and I by the way, my friend Brad gave me a complete cap kit for a CD32, but I'm still trying to figure out if these two motherboards have had their electrolytic caps replaced, because they are oriented correctly, and this is a revision 3 motherboard. I've seen some people say that all revision 3s have the caps backwards. I've heard people say that, you know, any of that they've ever seen have had them backwards. I'm wondering how many motherboards other people have seen. It's pretty rare to be, I'm in rare company myself as far as CD32 motherboards. I've had my hands on 4 of them now. Well, let's see, Brad's 1, my 1. Yeah, I've had my hands on 4 of them now, and that's got to be, you know, a rarity. Okay, so I don't see any errors here in the memory test. Let's go to the main menu and graphics test, and here's where we had a problem. It displays the text picture. So this is just displaying a picture, I believe, that's just stored in the DiagROM's memory. But here in the test screen, it's required to draw something, and it's not doing it. In fact, the computer is ceased, and I can't get out of it. I have to reset. So see, we are indeed getting somewhere here with the help of DiagROM. So I don't believe that there's any problem with the chip mem. There still could be something wrong with Akiko, because Akiko just, she has her fingers in so many different things. But it's Akiko beyond and beyond. I'm suspecting every single one of these graphics tests is going to fail. Oh, that one actually works. So the scroll works on good and bad. That's interesting. So now, oh boy, we're going to have to, it's just a raster. See, these are just displaying the colors. It's really weird. The test screen, it's called test screen 320 by 200. That's interesting. The test scroll is working. The test screen that draws, oh, there it goes. It worked. It worked this time. I'll be damned. I think it's pretty significant that it failed the first time, though. Intermittent. That actually sort of supports the possibility of there being an issue with a capacitor, because capacitors will change the behavior of the computer. It'll make things intermittent because they charge, they discharge. Their problems are based upon how they can or cannot, or in this case cannot handle the charge that they're given. I don't think that we have an open capacitor, which, you know, happens if they fatally fail. They're just dead. They don't pass anything through. But you know, if that's the case, the symptoms will be consistent. So, look at that. I can't believe that. I can't believe that's working now. It didn't work the first time. Yeah, wow. Okay, I'm just going to keep doing some testing and see if I can get some sort of consistency down. And so, Tweedledee, which is more dead than Tweedledum, is going to be potentially recapped. I'm thinking I want to recap this one, but and I have a set of CD32 caps that my friend Brad gave me. However, what I want to do is I want to determine if it's been recapped already. Because the caps are in these two electrolytics are actually in the correct orientation, as well as the other one. And the last motherboard I got from the same seller also had the caps in the correct orientation. I'm just wondering if this board has already been recapped. This one definitely has. My good board has been recapped. This is from Retro Passion. I bought a CD32 from them, and it has already been recapped. So what I'm going to do is because I actually have a capacitor tester, but I'm testing them in circuit can give somewhat false results. So I'm going to test the caps in circuit from this motherboard that we know work with the caps in circuit from this motherboard. So I'm going to get a piece of paper and write down the C numbers, C236, whatever. I'm going to write down all the cap numbers and write down the values that are on the good motherboard and the ones that are on the bad motherboard. And if they're too far out of range, then this is a good candidate for recapping. Then we'll recap this board and see if it works. So that's how we're going to proceed. These are just like, sewing pins in the clips, alligator clips of my ESR tester. Now the 10 microfarad and lower capacitors are difficult to measure at this voltage. If you look at one of these ESR charts, they don't really show up. They're like a grayed out area in the you go too high of voltage and too high of capacitance, and you go too low of voltage with too low of capacitance, 10 microfarad and below, and there really isn't a measurement. It's kind of off the charts or whatever. And this particular tester, if I test a 10 microfarad out of circuit, it will come up at 10 microfarad. But in circuit, usually you get a picofarad value. At least that's what's happening with these motherboards. I've never done a detailed comparison, and I don't know if I haven't tested enough capacitors, and usually when I'm testing capacitors, they're of a higher value, 4700, 3200, 2000, whatever. So these little tiny values are throwing me a bit. But it's very noteworthy to still test them even though they're off the scale and they're coming up with the wrong value and nothing that's useful as far as reading a value, because it could be open. These capacitors could have an open, and if they're open, this meter is going to say damaged part or unrecognized or whatever. Of course, being in circuit, that might throw that off. But if it's something that in one of the other boards comes up as a picofarad value, and then I get a damaged or unrecognized part here, well, then the capacitor is bad. So I'm looking for a large difference between the two boards, and that's the value of having this chart. And I'm going to put the chart up on the screen, and I'll also put it on my website, retrofriends.com. Click the Amiga link on the home page, and there should be diagrams like partway down the screen. Okay, so I'm all done. I've tested capacitors on all three boards. Here we have the capacitor number, the listed value of the capacitor, you know, the value of it out of circuit. And the green here, this column, is in circuit on the good motherboard. This is Tweedledee in circuit testing and Tweedledum in circuit testing. And it includes the value of the capacitor that's coming up in circuit, which is obviously in a lot of cases the wrong value because there's other components affecting it. But the reason to test it in circuit mainly is for the ESR reading. And this tester does ESR tests, so I wrote those down as well. So we have the ESR values for Tweedledee and we have ESR values for Tweedledum, and the ideal ESR is based upon a table. You know, you can get these ESR tables. There's actually one on the back of my tool, but it's freaking hard to read. It's got black writing on dark blue background. It's the dumbest thing I've ever seen. Anyway, so you know, we can see that the ESR values are a little bit high. They're pretty consistently higher than the ones on the good motherboard. And again, the good motherboard has some very high quality capacitors, I believe, as well as what I have in my capacitor kit. Now what's nice about the way now that I've done this is that one board is clearly better than the other. Tweedledum actually has better values across the board for all the capacitors. So if I was to pick a board to recap, it would be Tweedledee because it's further away. However, all the values are like 10% or something. They're really not that far off. I mean, I guess this is 20% here. So it's like 10% for Tweedledum off and 20% for Tweedledee. I don't know. In some cases, the ESRs are identical or very close, but it's pretty consistent that Tweedledee has more drift away from proper values. So my question is, and you can leave a comment below because I'm about to end the video. It's long enough, and I'm at a good a good point at cutting the video off and proceeding and doing a follow-up video. But leave a comment below if you feel that I should proceed with the recap on the weaker motherboard, or see, what I'm thinking is that these values aren't far enough off to make these boards not boot at all. You know, it is sort of a coincidence that Tweedledum works with DiagROM and it has closer values, so it's more closer to a working board as opposed to Tweedledee, which doesn't do anything with DiagROM in it. So you know, that could be just a coincidence. I'm thinking it is. What I'd like to do instead of going to the trouble of recapping the board is there's a couple things I can do. I can measure the ripple on the power rails and various targets of these capacitors, the circuits these capacitors. I'm not concerned about audio. You know, a lot of these are audio capacitors. I'm not going to worry about those. But the ones that deal with power, or perhaps maybe if some of them, usually this isn't the case, but maybe if some of them are part of the signal path, the signal bus, one of the buses. But anyway, I'd like to proceed with actually a logic analyzer. I have a logic analyzer that can monitor like 8 channels at once, I think. I can look at the good board, and there aren't any documents that are very detailed on, you know, what the computer's doing when it boots up. There's a couple of documents on not the CD32 but older Amigas where it does have like a sequence of events. What it does this and it checks this and it does this, and I think I'm going to use one of those documents in conjunction with a capture. I can look at the document. Hopefully the document will tell me which, you know, point me in the right direction about which signals I should monitor, and then actually I will put a logic analyzer on that. And what a logic analyzer is it basically is a oscilloscope, except it does multiple channels, a lot of channels at the same time, and it does it over a period of time. It captures the data, and it only needs to capture it for 10 seconds or 8 seconds or however long until we get the CD32 logo on the screen, and then we'll be done. We want to see what's happening on the board in logic, and then hook up to a bad board and compare it to a good board that's working. And if we do that, we're gonna learn a lot about how the CD32 or the Amiga 1200 and even some of the older ones are kind of all based on the same startup sequence, where it checks the processor and it checks the RAM and it checks the ROM. It'll probably do it in the same sequence. Whatever document I find, I'll try to hopefully find one for an AGA machine like a 1200, but I think it's just a generic document. But anyway, so I'm going to go do some searching and research on that. But that's the end of this video, and I thank you for watching, and stay tuned for more. We're going to keep going on these boards, but this is not an easy task, but we're going to move forward and try to be successful. Thanks for watching, friends. Bye.